I'm gonna do some math. Got my calculator in my pocket. I'm a falcon, about to do some math. This will be so awesome. Alright, today we're talking about my favorite shape and yours, triangles. Alright, so triangles. Some stuff you've probably already learned before, but just in case you haven't, we're going to cover it again. Classifying triangles. Two ways to do it. One way is classifying them by their angles. Alright, so if you have a triangle that's called equiangular, that's a triangle where all three of the angles on the inside are the same amount. Okay, and when this happens, it's always going to be 60 degrees. They can't all three be 70 or 90 or whatever. They all got to be 60 if they're all equal. So here's an example right here of a triangle that's equiangular. Also, these little arcs right here in the angles indicate that these three are the same amount. So you don't have to see the angle measure. There being one arc here and one arc here and one here means that those are all the same angle. Also, you have acute angles. Acute angles are angles that are less than 90 degrees. So an equiangular triangle is an example also of an acute triangle because all the angles are less than 90. Then you've also got a right triangle. A right triangle has one right angle. As you can see right here, there's one right angle. It can't have more than one or it wouldn't be a triangle. So it's got to have one right angle to be a right triangle. And then an obtuse triangle is a triangle where one of the angles is obtuse, which means more than 90. So you can see right here, this angle is 120, which is more than 90, so that is an obtuse triangle. We can also classify triangles by their side lengths. Similar to equiangular, you have equilateral. You can see the keyword in there being equal, right? So this is a situation where all three sides are equal or congruent, as indicated right here by these tick marks on each side. So since there's one tick mark on each side, that means those sides are all the same length. Just like one arc on the angles indicates that those angles are all the same amount. Okay. Something just to know: if a triangle is equilateral, it is also equiangular, and if it's equiangular, it is also equilateral all the time. Also, you have isosceles triangles. This is where only two sides are congruent. So not all three, but just two sides are congruent. The third side is something different. And then the last kind you have are scalene triangles, and that's where they're all three different lengths on the sides. Okay, so I'm going to go ahead and pause it real quick and let you guys classify these four examples right here. I want you to classify by their angles and by their sides. So there should be two words to describe each one of these four triangles. All right? So I'm going to go ahead and pause it, and you guys try them, and I'll go over them. Alright, so you can see right here this first triangle is obviously equiangular because all angles are 60, and it's equilateral because all the sides are 6.3. This one right here is obtuse because you see you have a large angle here that's bigger than bigger than 90, and scalene because all the sides are different. And this one, these tick marks indicate that these two sides are equal, which makes it isosceles, and all the angles are less than 90, so that's an acute triangle. The last one, D, is a right triangle because you can see the right angle. It's got one right angle, and it's scalene because all the sides are different. All right, so hopefully you guys got all those. All right, so let's go ahead and look at this triangle real quick. So actually applying our knowledge of triangles to solve some problems. So find D if triangle RST is equilateral. So if this is equilateral, what do we know? We know all the sides are the same. This is the same as this, and it's also the same as this. So how can we find D? Well, if we know that this side equals that, this expression should equal that one. And similarly, this one equals that one, and this one equals this one. So you can set it up a lot of different ways. What I'm going to do is just do D plus 2 equals 12 minus D. And you could set it up with these two equal to each other or these two equal to each other. Either way is fine. So now we're going to draw a line down our equal sign, and I'm going to combine the D and the minus D. So to move the minus D, we need to add D. Right? We talked about if it's on the opposite side of the line, we do the opposite sign. So it's a minus D. That one's over here. So we're going to add D. So that'll cancel and bring down our 12. D plus D is 2D plus 2. And then we subtract 2 from both sides. So that leaves 2D over here. Subtract 2 from over here. That leaves 10. And divide by 2. So D equals 5. So we found D. knowing that this is an equilateral triangle. Alright, so right here, I want to pause it and let you guys try this one. This is an isosceles triangle, which means two sides are equal, and they indicate this side is equal to that side. So this 2x is just kind of extra information, right, that you don't really need at all. You don't really have to use it for anything. We know this is equal to that, so we set those two equal. Alright, and we get x más 9 for my Espanol speakers, es 3x menos 9. So we menos x, and that leaves 9. Es 2x, 3x menos 1x es 2x menos 9. And then we más 9. So menos 9 más 9 is 0. 2x comes down. And then we got 9 más 9 es 18. And dividido 2, x es 9. So x is 9. Let's go on, keep on cruising. Not bad for you guys to learn a little Spanish also. Those of you that speak English. It's a good thing for everybody to know. Alright. So now, something we already know, but just need to review a little bit. The triangle angle sum theorem says that the sum of the measures of the angles of a triangle has to equal 180 degrees. Any triangle, no matter how we classify it by sides or angles, the three angles on the inside have to add up to be 180 degrees. So in this example, angle A plus angle, that's not an angle, that's an A. Angle A plus angle B, plus, let's do it the third color, why not? Angle C has to equal 180 degrees, has to. Alright, so that's what our angle sum theorem tells us. So let's use the angle sum theorem right here to solve some problems. So up here we've got a triangle with 135 degrees, 24 degrees, and we don't know this one. But we do know that three angles have to add up to be 180. So if we call this x, we can set up an equation. We can say x plus 135 plus 24 has to equal 180. And then we can solve this. So you just simply minus your 135 and minus 24 from both sides. Minus 135 and minus 24. That'll leave x over here. And then we do 180 minus 135 and minus the 24. You're going to get 21 degrees. Okay, so we know now that this x is actually 21 degrees. And if you want to double check, you can always add these up. 21 and 24 is 45, and 45 plus 135 is going to give you 180. So that's one way to check it. Just add them up, make sure they equal 180. All right, let's do this next one right here. So I'm given these two, and I'm also given this. We know that this means this angle is 90. All right, so set it up the same way. 6x plus 60 plus 90 should equal 180. The three have to add up to be 180. So I add all three of them and set it equal to 180. Now we're going to minus 60 and minus 90, which is the same thing as just minusing 150. Okay, so I'm going to put minus 150 over there. And then those will cancel out. I'll bring down the 6x, and 150 minus 180 minus 150 is 30. Divide by, not 5. What are you doing, Coach Shipley? Silly Coach Shipley. Don't make mistakes like that. 30 divided by 6 is 5. So we got x equals 5. Alright, so I want you guys to see if you can try this third one over here. Good luck. I'm going to pause the video. You guys go ahead and pause it, try it, and then I'll come back and show you the right answer, see if y'all got it. So I had to add up the three angles. I got 94 plus x plus 41 plus 55. I went ahead on this one and just combined all of my numbers on the left side together to get 190. And then just to get x by itself, I need to subtract 190 from 180, and that gives me negative 10. You're like, oh, it's negative. I did something wrong, Coach Shipley. What do I do? Save me, save me. No. So this is actually right. X can be negative as long as when you plug it back in, right, you still get a positive for the angle. Okay, the angle cannot be negative, but your x can actually be negative. So 94 plus negative 10 is 84. And if you want to double check now, you can add 84 to 41 to 55 and make sure they all add up to equal 180. Because once we subtract 10 from 94, it tells us our angle is 84 degrees. But x can be negative. Keep on cruising. Okay, so now it's going to get interesting. So for those of you that like a challenge and you like some tough stuff, that's what we're getting here to now. Because you gotta remember some of the angle relationships we talked about. The main two that you're going to have to remember are vertical angles and linear pair to do these problems. Okay, so what we know about vertical angles are equal to each other. Two angles that are vertical angles are equal. Linear pair are two angles that are supplementary, which means they add up to be 180. Okay, so supplementary means they add up to be 180. So I'll put that here just as a little reminder. So these two things are things you got to remember to do these problems. So we're going to use both of these, all right? Now, go ahead and leave those on your notes, but I'm going to erase them from here just to create more space. All right, so on this problem, I want to find this angle, but I only know one other angle. So if I add these together, I'm not going to be able to subtract everything from 180 that I need because I don't know the third angle in the triangle. But because I know this angle is 125, I can see these two lines cross to form vertical angles. 125 is the same as this angle. So because they're vertical, this angle is the same. So I can go ahead and just put 125 in there and say, all right, well, this angle is also 125 because it's a vertical angle with this one, which is 125. Now I can set up my equation. So I can say this is x plus 125 plus 30 equals 180. And then whenever I subtract both of those, I'm going to get 25 for x. And that's also 25 degrees because that's the only thing on that angle. All right. Now in this one, kind of similar. But I don't know any angles this time. I know none of the angles inside, and I want to find this one. So in order to do that, what can I do to find the other two angles? If I can find the other two, then I can find this one because I know they got to all add up to be 180. So how can I find this angle? Well, over here 60, similar to the last problem, it's a vertical angle with this. So this is also 60. You can just kind of throw it in there. All right, now this is different. So these aren't vertical angles because they're not across from each other. They're right beside each other. But because these two angles combine to form a straight line, as you can see right here to here, they make a straight line when you add them together. They're a linear pair, which means they're supplementary. They add up to a straight line, which is 180 degrees. Straight line is 180 degrees. So since they add up to be 180, I know that I can just take away the 150, and that'll tell me the part that's left. Okay, if this part's 150, the part that's left will add up to be 180. So what is that? Obviously it's 30. So this angle is 30, this one is 60. So now we can make this our x and say x plus 30 plus 60 should equal 180. All right, so then that's going to combine to be 90, and we subtract 90, and x equals 90, big scary 90. It's like eyeballs and fangs, and it's like rah ha ha ha. Alright, so yeah, 90 is the answer, and that's what the angle measure right here is. So these take a little bit of thinking, okay? Take a little bit of logic and reasoning abilities, alright? So they'll challenge you a little bit. Let's keep on cruising. Let's let you guys try these four, okay? So they're a little bit tougher than the ones I just did, but I got faith in you guys. Y'all are smart. Y'all can handle it. Go ahead and try them. So these are a little bit tough, but let's look at them real quick. So right here to start from this one, we see that this 20 is a vertical angle right here, so we can just throw that 20 in here. All right. Then down here, we see that this is 50, which makes a linear pair with the angle inside this triangle. So 180 minus 150 is 30, or sorry, 180 minus 50 is 130. So change that right there, that 100. Let's take that off of there, maybe. It'd just be 180 minus 50. Would give us the 130. So then once we know this is 130 and that's 20, okay, then we add those up to get the 150. And when you get 150 taken away from 180, that leaves 30 degrees left right here. So now we know this is 30. So 30 plus this, because these make a linear pair, right? They make a straight line. The x plus 158 and 30 have to add up to be 180 because they make a straight line. So we set that up and combine the 158 and 30, subtract 188, and get x equals -8. Alright, again, it's okay if x is negative. This one, again, vertical angle right here, so we just throw that 105 in here. This is also a vertical angle, so we can just throw x plus 58 in here. And now we've got three angles in a triangle that add up to be 180. So we add up 25, 105, and 58 plus x. Alright, put all those in here together. Combine them, again get 188, subtract 188 from 180, and get x to be -8 again. Alright. So then this last one, these last two are a little bit tougher probably. Alright, right here you've got a linear pair. So these two have to add up to 180. So take 122 away from 180, and that leaves 58. So this has to be 58. Alright, and then once we know this is 58 and that's 85, these three have to add up to be 180. So I say, okay, well, I know these two. Take those away from 180, and that'll leave me with 37 degrees for this angle. So I know that one's 37 now after subtract. Now vertical angles, so 37 can just be thrown right into here. And then right here I've got a linear pair with these two. So do 180 minus the 134, we'll leave 46 to be the other angle of my linear pair. Now I know this is 37, that's 46. These three are the three angles of the triangle, so they got to add up to be 180 using the triangle sum theorem again. So since I know these two, I can take them away from 180, and it'll tell me what's left, 97, to be this angle. And then last step is a linear pair. These two have to add up to be 180, so just take the 97 that I know away from 180, and that leaves 83 for my answer on this one. And the last one, right here, let's start with this one, a linear pair. These two add up to 180, so take 85 away from 180, leaves 95. Then I've got 40. They have to add up with this one to be 180 because they're the three angles of a triangle. Take those away from 180, leaves 45 to be here. Now this is a little trickier because you've got three angles that add up to make a straight line. So all three of these must add up to be 180 because they all form a straight line. So I know this is 85, I know this is 45. So if I subtract those two from 180, it should leave me with the third angle, which is 50. So there's that third angle, 50. And then right here, vertical angles, so I just throw the 80 in here, and then I use those two with this triangle to find the angle of the third. I know two of them, take them both away from 180, and that'll leave me with the third angle, 50 degrees. Alright. So real quick, I'm going to let you guys find V on this, and then we'll talk about this question real quick. Three angles have to add up to 180 because they make a triangle. Take 50 and 78 away from 180, it leaves your third angle 52. And then these make a linear pair, so they have to add up to be 180. So take 52 away from 180, and it leaves 128. So now what do we notice about V? How does V relate to the two angles that we were given? Alright, so 50, 78, and this is 128. Looks like these two add up to be 128, which is an actual theorem. Okay, it's called the exterior angle theorem. So what it says is the measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So just to break that down a little bit, this is your exterior angle. So this is the exterior angle, and then in here you've got your two, what they call remote interior angles. Alright, so I'll underline those. Okay, these are your two remote interior angles. So what we're saying is just what we did on that last thing, that last problem. The angle measure of the exterior angle equals the sum of these two. So right here, angle A plus angle B equals angle ACD. ACD, right? We can call an angle by the three letters. So we're going to use this a little bit. All right, so I'm going to do one problem right here for you. So this is our exterior angle. We have two interior angles. So we know by the exterior angle theorem that these two must add up to be this. So that's how we set up our equation. We just add up those two angles. Give some room here. 8x minus 4 plus 6x minus 10 should equal 140. Alright, so 8x and 6x is 14x. Minus 4 and minus 10 is minus 14. Alright, so now I'm going to add 14 to both sides. And bring down the 14x. 140 plus 14 is 154. And divide 14, divide 14. So x is going to equal 11. Alright, so that's how you do that one. So I'm going to pause this real quick, let you guys try the other exterior angle problem. So on this one, you've got your two remote interior angles, so they should add up to be the exterior angle. So I set that up, 5x minus 10 plus 80, right? The two remote interiors should equal the exterior, 11x minus 2. Right, once I set it up, I just combine my minus 10 and 80 into 70. Right, then I'm going to minus 5x from both sides. 11x minus 5x is 6x. Then I add 2, get 72, divide by 6. 72 divided by 6 is 12, so x is 12. I hope you guys got that. Now it's time to work, 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 work. Hope you enjoyed the video. Happy mathing.